Hi, welcome to No-Code Machine Learning app. In this video, we are going to look at the regressor algorithms. This option in the No-Code Machine Learning app automatically selects the best algorithm based on the training dataset. So let's begin. So this is the interface for the machine learning regressor, and as we mentioned earlier, this option in the no-code machine learning app automatically selects the best algorithm based on the training dataset. In step 1, we select the training data file, and the training data file must be in .csv or in .json format. We are going to use NYC taxi fare data as part of this example. We are extremely grateful to the authors for making this data available for research and training. So we choose the taxi fare training data. This dataset is fairly large. It has slightly more than 1 million rows of data, and we are going to use that to train the machine learning model. So we have chosen the taxi fare training.csv. Just a note on the structure of acceptable.csv file for regressors in the no-code machine learning app. The first row of the .csv file must have the column names. For example, here we have day, outlook, temperature, humidity, wind, and play tennis. Then we have rows of data: day D1, outlook sunny, temperature hot, humidity high, wind weak, and play tennis 0. One other note is that the target column in this example is play tennis. For all regressors as part of the no-code machine learning app, the target column, in this case play tennis, must be of type either double or integer. They cannot be string. So here we have 0, 0, 1. If you prepare your .csv file following this structure, you should not have any problem using no-code machine learning app to train your machine learning model. In the next part of the app, we have the option to select all the features from the training data table, or we can visually select custom feature set. So in step 2, we can select all the features. So these are the features available as part of the training data set. In this example, fare amount is going to be the target column. This app also gives you the option to clear the selection, and you can go to step 3 and view the available features from the training dataset and only choose the specific features that you would like to use for training your machine learning model. The difference between step 3 and step 2 is that in step 2, all the features will be selected automatically. In step 3, you are able to visually select the specific custom features that you would like to use to train your machine learning model. So in this case, we can select payment type, we can select trip distance, and we just want to select fare amount, which is the target column. So in this case, we can just choose only 2 of the available features. And so we have custom features here, trip distance and payment type, that we are going to use to train our model to predict fare amount. Once we have done that, then in step 4, we have to confirm our selection. So once we select the specific custom feature that we have here, we can move to the next section. This part of the app allows you to automatically split the training dataset into 80% for training and 20% for evaluation. That you can do automatically in step 5, or you can choose a completely different evaluation data file that is different from the training data file. So that option is also available. So in this case, we are going to just select automatic random 80-20 split. One thing to note here is that the app makes sure that the specific custom features we chose over here, trip distance, payment type, and the target column fare amount, is exactly what is also chosen here, trip distance, payment type, and fare amount. So this ensures, by providing visual confirmation, that the features we selected for training and features that are selected for training and evaluation match exactly. That is also true even if we selected a different evaluation data file. Once you have done that, and again you have the option to clear that selection, and you can also select a different evaluation data file if you choose to do that. Anyway, for our example, we are going to choose step 5, the automatic 80-20 split. In the next section, we have to specify the target column name. In this case, it's going to be fair amount. That is what we want to predict. The spelling of the fair amount should be exactly as it appears in the evaluation part as well as in the training part of the app. So fair amount here should exactly match the fair amount here. Otherwise, we're going to get an error from the app saying that the columns do not match. But in this case, we have the correct target column, fair amount. In step 7, we train and evaluate the ML Regressor algorithm. So the training and evaluation is complete. So at the top, we have the automatically selected algorithm based on the training data set, and automatic selection is boosted tree regressor. You can review the hyperparameter values here. You can review the performance in terms of max error and mean square error. And slightly below here, we have the same data in a much more easy to read format. We have the training matrix, maximum error, and training matrix RMSE, validation matrix max error, and validation matrix RMSE, and evaluation matrix max error, and evaluation matrix RMSE. So you can see how your trained machine learning regressor actually is performing. And we provide a brief definition of both of these performance metrics. If we are happy with the trained ML regressor matrix based on the performance metrics, we can also choose to save the matrix tables in a .csv file. This is completely optional for step 8. We provide this as an option to you so that across multiple runs or sessions where you are trying to find the best combination of features to get the best machine learning model, you will be able to save this matrix in .csv file and be able to compare those across different runs or sessions to see which one gives you the best performing machine learning model. So we can save that here in this step. We are going to save the performance matrix in the prediction folder. So we are going to call this performance matrix and save that as a .csv file. Now we can go and see what we just saved. So let's go to the folder performance matrix, prediction performance matrix, and here is the file, and we can open that using Numbers app. And here is the performance matrix that has been saved for you. So you have validation RMSE, evaluation RMSE, training max error, evaluation max error, training RMSE, and validation max error. Again, this option is available to you across multiple runs that you might try where you are combining different features to see which feature set gives you the best performing machine learning model. And by being able to save this performance metrics for each of the runs or sessions, you will be able to compare those and do further analysis. We are happy with the performance of our machine learning regressor. We want to use the trained machine learning model to predict fair amount from a file that has the features that we have selected, in this case trip distance and payment type, but those have not been used for predicting fair amount. So in step 9, we are going to select the file taxifare data for fair prediction. So we are going to open this file in .csv format. You can note that for visual confirmation of selected features from the data file that we want to use for predicting the fair amount, the features selected here are shown for your convenience. You can see the feature here is trip distance and payment type. And you can see it's exactly the same features that were used for training and evaluating the machine learning regressor: trip distance and payment type. So this ensures that the trained machine learning model is going to predict on data for which it has been trained. Specifically, the features match exactly so that the prediction will be correct. So we go to step 10 and run the trained machine learning regressor to predict the data, and the prediction is complete. And we can save the prediction result in .csv format. So we can save that prediction result, and we're going to call that fair amount. So we are saving the prediction result for the fair amount. We save it. Let's open that folder and see what we saved. Save prediction result, and we have the file here, and we can open that using Excel spreadsheet. As you can see here, we have the Excel spreadsheet, and the columns are as we expect. So we have payment type and trip distance as the two features that we had trained our machine learning model to be used for predicting the fair amount. And the prediction result shows here the fair amount that has been predicted based on the values of payment type and trip distance. And fairly large file, so we have about 1500 plus rows of data that has been predicted using the machine learning trained regressor. And you can have a larger data set that you can use with the machine learning regressor as part of the no-code machine learning app. Once you have done that in terms of predicting fair amount, one other option that's part of no-code machine learning app is that if we are extremely happy with the trained machine learning regressor, we would like to use that as part of developing intelligent iOS, macOS, watchOS, or Apple TV apps. So this app also allows you to save that trained machine learning model in .MLModel format. So you're going to provide the model description. So we are going to call this predict fair amount, and we can call that predict taxi fair amount. Author John Smith, license MIT, and version 1.0. So now we are able to save this model. We save this in a folder. We can create a folder for mobile app dev. We can create that folder, and we can save this as predict fair amount.mlmodel, and we can save the trained regressor for use with developing mobile application or macOS or watchOS application. Let's take a look at what we just saved. And as part of that folder, we have the mobile app dev, and here is the model. We can open that using Xcode to inspect the content of that machine learning model. So it's called predict fair amount.ml model, machine learning model, and it's predict fair amount, pipeline regressor, author name, description, and then the input type, trip distance, and payment type, and output is fair amount. As you can see, this model can now be used for developing mobile application. So to recap, this part of the no-code machine learning app allows you to automatically select machine learning regressor that is best given the dataset that is being provided for training the machine learning regressor. it automatically selected here, in this case, boosted tree regressor. It provides you with varieties of performance metrics, so you can decide how well the regressor is performing based on the training dataset. It has the features so that you can either select all the features from the training data table, or you can select specific custom features from the training data table. And if you do that, you need to confirm your selection so the app knows these are the features that you would like to use. Then you have the option to automatically split the training data file into 80% training, 20% evaluation, or you have the option to select a different file for evaluation, which is completely different from the training data file. Once you have done that, you need to enter the target column and then train the machine learning model. Then you can select a file that has not been, or data that has not been used for prediction, and you can use that data to predict the fair amount, and you're able to save the result of the prediction using the trained machine learning regressor. And then this app also gives you the option to actually save the trained machine learning model for developing intelligent iOS, macOS, watchOS, or Apple TV apps. I hope you enjoyed the video, and thank you for watching.